Okay, so this is lesson 5-6, graphing proportional relationships. So the first part we're going to be looking at their proportional, or we're determining if they are. So proportional and non-proportional relationships. So example 1 says determine whether each relationship is proportional by graphing on the coordinate plane and explain your reasoning. So we're going to have to graph these. They give us a table. It says the black mamba is the fastest snake in the world. The table shows the distance the snake travels for several different times. Is the distance the snake travels proportional to the time? So remember, we've talked about this before. Anytime they give us a table like this, it is always set up as x first, then y when they give it to us. When it's up and down, it's always x right here, and then y right here. Okay, so these are the numbers they give us. Time is here, distance is here. So when we graph it, you really just draw like an L shape. Your X is always this one, just like on a big coordinate grid. X is your horizontal line, Y is the vertical line. So X would go here. Since it says time is first, time is here, distance is here. So if you notice, distance goes up to 20, so they counted by 5s. That's fine. You can count by 1s, 2s, as long as you have a pattern. Can't just say 1, 2, 7, 8, 12. Like, that makes no sense. So then we just graph the points that they give us. 0, 0, 1, 5, 2, 10, 3, 15, and 4, 20. So once you graph it, we can see it makes a straight line. There's 2 things you check for, and you might write this down on if it's proportional or not. The 2 things you always look for: does it make a straight line? So you could put how to be proportional. Put straight line, and it has to pass through the point 0, 0. So straight line and passes through 0, 0. If it meets those 2 things, then it is proportional. So once we've graphed this, we see, okay, it makes a straight line and it passed through 0, 0. So yes, this is proportional. Just like before, what we did, we set it up with our constant to see if there was one, and we put y over x. We can still check that from our points. 0 over 0, well, that equals 0. But that one is just to determine if it went through the origin. 1, 5, I would do 5 divided by 1. That's already simplified because it's over 1. 10 over 2, that's 5 over 1. Once you simplify it, you divide them by 2. 15 over 3, you can divide by 3. You still get 5 over 1. 20 divided by 4, you still get 5 over 1. Since we got the same thing over and over and it passed through 0, 0, this relationship is proportional. So you could just say yes, proportional. Okay, so we have to graph and then tell me yes, it's proportional. Whenever it says explain your reasoning, going back and showing me this piece right here is explaining it. Okay, so now let's see if it'll let me scroll down. There we go. Okay, let's look at another example. B. A candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the height of the candle proportional to the number of hours it burns? So is the height proportional to the time, the number of hours it burns? And it says make a table to find the height of the candle after 0, 1, 2, 3, and 4 minutes. So on this one, they did not even give us the table. They just said after 0, 1, 2, 3, and 4 minutes. So if you're reading the problem, says, is the height, let me get a pen, is the height proportional to the number of hours? If you remember the last lesson, they always tell us y to x, y over x. So they told us height first, so height is your y. I'm having to write this with one finger on my offhand. And hours is your x. So height, hours. When we make a table, we always put x first, so time, and your y second. So height. So then they told us what to plug in for time. So it tells us the candle is 20 centimeters tall. So that means after 0 time of it burning, it's already 20 centimeters tall. It burns at a rate of 2 centimeters per hour. So they're telling us after 1 hour, it burned 2 centimeters. So it's no longer 20 centimeters tall. It burned down 2 centimeters, so 18. So after 2 hours, you would take 2 more off. It'd be at 16. 3 would be 14, and 4 would be 12. So then when we make our graph, you just make an L shape. I don't want you writing all these lines in here. You're just doing this and graphing it from there. Time is on bottom, and our height is up the side. You have to actually label it with words. So then our height goes from 20 down to 12, so just make sure you have enough. If you need to count by twos, that's fine to ensure that. And so forth. I'm not going to draw the whole thing because it's right here. So then we would graph it. So at 0 hours, it's 20 centimeters tall. After 1 hour, it's now 18, 2 is 16, 3, 14, and 4, 12. So when we graph that, it does make a straight line. That's one of the qualifications. So that means there is a pattern, and that pattern is that it burns 2 centimeters every hour. But is it proportional? The answer is no. Okay, it's not proportional. You could say not proportional or non-proportional. Okay, because it did not pass through 0, 0. It started out that after 0 amount of time, it was already 20 centimeters tall. So it's non-proportional. Okay, what I want you to do is you are going to try 1A and 1B. On these, they already give you the table on both of these. So they're similar to this example A that we did together, okay? But you're going to try both of these. It says determine whether the cost is proportional to the number of items in each relationship by graphing on the coordinate plane and explain. So you're going to graph it, and your final answer is telling me yes, it's proportional or non-proportional. Okay, so pause the video and try those, and then I'll go over it with you. So on 1A and 1B, we are having to determine whether the cost is proportional to the number of items. And it said by graphing. So on 1A, we have number of tickets and costs. If you remember, they always give you X on top and Y on bottom when they give you a table like this. So if we graph that, because we're talking about cost and number, in this case, number of tickets, we're not going to have negatives on this. So we can just do an L shape because it's going to be positives only. So this means X has to go on bottom. Number of tickets, you have to label that. Cost goes up the side, and it's in dollars. Okay, so then you graph them. So I'm just going to go ahead and count by twos on mine. It doesn't matter, you can count by ones or twos. Or something else, as long as you do it consistently. Okay, so number of tickets 2, cost is 6. So that means number of tickets is 2 and the cost is 6. I would have a point there. Number of tickets 4, the cost is 8. 6 would be 10. Let's see, 8 and 12, and then the last one would be 10 and 14. So I know my graph may not be the straightest, nice and neatest, but this does make a straight line. Okay, that's one of the qualifications. If you remember, it has to have 2 qualifications to be proportional. It has to make a straight line, of course, then it has to pass through 0, 0. So on this, we see it makes a straight line. If I were to continue my line, or plug it in the other way, does it go through 0, 0? 0, 0 is the corner right here. No, it doesn't, okay? They are sort of proportional as far as there's a pattern. Okay, but if we notice, when the number of tickets would be 0, the cost would be $4. Okay, so it's not 0, 0. So this one, your answer and what it means by explain, I could have also set them up. 6 over 2 is 3. 8 over 4. Did I do that? Oh, yeah. 6 divided by 2 is 3. 8 divided by 4 is 2. We're getting different numbers. 10 divided by 6 doesn't come out to either of those. So you're not getting that pattern. So that will count as explaining, okay? Showing your work. And then you would have to say not proportional. Okay, so now let's look at 1B. Now we're talking about number of hot dogs and the cost. So again, your X is first, then your Y. So when you set up your graph, just like in a coordinate grid, this is always your X, it's horizontal, Y is up and down. So I have number of hot dogs on bottom and the cost on the side. I'm going to count by twos again, but you can count by ones on this, it doesn't matter. And then if you notice, the cost goes all the way up to 30. So I may count by, it's still going to be a lot. I'll count by threes. 6, 9, 12, 15, 18. I'm going to end up having to go up. 21, 24, 27, 30. Okay, I know my graph's not the greatest. Okay, so I have 2 hot dogs cost $6. Again, I could have 6 over 2. That's 3 over 1. Then I have 4 hot dogs cost $12. 12 divided by 4 is 3 over 1. 6 hot dogs cost $18. So 18 divided by 6 is 3 over 1. Sorry, I keep forgetting that over 1 because we're talking about proportional. 8 hot dogs cost $24. 24 over 8 is 3 over 1. And then the last one, 10 hot dogs cost $30. So 30 over 10, because remember when we're setting up our proportion or our constant, it's always y over x. So cost over hot dog. 3 over 1. Okay, so what that means, we're getting the same constant over and over. It makes a straight line. That also means if I went the other way, I could divide by 3, since it's 3 being multiplied by 3 each time. 2 times 3 is 6. 4 times 3 is 12. And it's counting by 2's up here, so if I went to 0, 0 times 3 is 0. Okay, or, yeah. So that means it would pass through 0, 0. I know my graph, it's because I tilted it a little bit, it kind of looks like it is curved. But it is a straight line. It does pass through 0, 0. So it's straight line and passes through 0, 0 since it meets both of those qualifications. Yes, it's proportional. So example 2 says the length of the stretch in millimeters of a spring is proportional to the weight attached to the end of the spring as shown in the graph. So on this one, they give us this graph. Here's the length of the stretch and the weight. So weight is your x, the length is your y. Find and interpret the constant of proportionality. So they're already telling us it's proportional, so we are trying to find what the constant is. So we do y over x. Okay, like what we've talked about, it's your y over x. So they give us 2 points in here, 1, 5, 5, 25. So it doesn't matter which one you use. This says, since this one already has a 1, we'll use the other one, 5, 25. So length on top, weight on bottom. So 25 over 5, because every point, if you need to write that down to refresh yourself, is always x first, then y. So here's x, here's y. So to put y on top, x on bottom, we would have 25 over 5. That simplifies to 5 over 1, or just 5. So does my other one, 5 over 1. So our constant, or in this case unit rate, what's being repeated over and over, it's just another word for it, is 5 millimeters of stretch per gram of weight. So then it says Explain what the points 0, 0, 1, 5, and 525 represent. So you're just putting it in terms of the problem. X was weight, Y was length. So 0, 0 represents the length of stretch of the spring is 0 when no weight is attached. The 0.15 represents that the length of stretch of the spring, so it stretches out 5 millimeters when 1 gram of weight is attached. And then 525, same thing. It stretches 25 millimeters when 5 grams of weight are attached. So what I want you to do is you're going to try number 2. They give you a graph. It says Keith plants a seed every 3 days after the seed sprouts. He measures the height of the plant. The graph shows his results. So find and interpret your constant. Remember, it's y over x. Then explain what these 3 points mean. On problem number 2, it says Keith plants a seed every 3 days after the seed sprouts. He measures the height of the plant. The graph shows his results. So I've drawn the graph here. Okay, we have height up the side and days on bottom. So that would mean your height is your y, days represent your x. Okay, and then we have a graph right here. So if we look at this, we can already tell it's a straight line and it passes through 0, 0, which since it met those 2 things means it is proportional and there is a constant. Okay, so problem A says find and interpret the constant of proportionality. So what we do, our constant is always set up y over x. So in this case, my y is height. So in this problem, it's going to be the height over x, which in this problem is the days. So they went ahead and told us 3 points. So I'll start off with the first one, 3, 6. Every point is always set up x, then y. So if I'm putting it y over x, height over day, I'm going to have 6 over 3, which equals 2, or 2 over 1. Okay, my next point, 6, 12, I do y over x. That simplifies to 2 over 1 again. And then the last point, 18 over 9 equals 2 over 1. We knew we would get the same thing over and over, okay? Because it was a straight line and it went through 0, 0 means it is proportional. We just had to figure out what our constant is. It's 2 over 1. And what it means by interpret it, well, remember this is y, this is x. So that just means the height is 2 millimeters on day 1. So after each day, how you would actually interpret this, each day it grows 2 millimeters. That's what that means by interpret it. Can you understand in relation to the problem? So after each day, it grows 2 millimeters. That's what it means by interpret your constant. So A, our constant was 2 over 1. Each day, you literally would write that. Each day, it grows, or the seeds grow, 2 millimeters. Because the height was measured in millimeters. Okay, problem B said, I think just interpret, explain what the points 0, 0, 1, 2, and 6, 12 represent. Okay, so on this problem, 0, 0, again, you're just talking about it in relation to like what we just did. 0, 0 would mean after 0 days, the seeds have grown 0 millimeters. After 1 day, the seeds have grown 2 millimeters. After 6 days, the seeds have grown 12 millimeters. That's what that means. You would write that. I would honestly just make you write it once. Okay? And to me, it's always 0, 0 gets a little confusing when you're trying to interpret it. Do it for one of these 2. So after 6 days, it would grow 12 millimeters.